Hi everyone, welcome to this class with me. My name is Funke Yusuf, and I just started this YouTube platform, and we are going to start a course which I call AI agents. So this is my first course on AI agents, and I will be looking at some series of how to build agents, agentic design patterns, and I will be building some use case enterprise AI agents, some use cases. So we'll look at most of the design pattern used in enterprise agentic AI system, and then we'll try to look at how the code works, how to call Claude API or OpenAI API, and how to develop AI agents in general. So let's start with what is AI agents. Of course, we know LLM, we have the language model, we have our generative AI, we know our we know our chatbots, ChatGPT, we know our Claude, we know Gemini and Grok, and so many of them out there. Okay, so those are like the brain of an agent. They are called the brain of an agent. They are large language models on which agentic systems are built upon. Okay, so autonomous agents are intelligent software systems that can reason, decide, adapt, and act independently, okay, in changing environments. They can be reason on their own, they can think strategically, they can take decision, they can adapt to their environment or to the situation they find themselves, and they can act independently without any human intervention or instruction. Okay, so unlike traditional software that follows fixed rules, okay, you have to program what to do and what the application should do. Agents understand constant or they can understand context. They also can make decisions dynamically without your efforts or without your guidance as a human being. So not every system are agentic anyway. So most of the systems we have out there are just workflow. So in this lesson, we are going to be looking at or how you can identify an agent and which agent can you call a workflow or semi-agent. You understand? So why are agents now possible? Why are they possible? Like I started earlier, so agents are possible because we have LLM, we have large language models like OpenAI GPT, we have Claude, and we have Gemini, we have LLM like Llama Index, DeepSeek, Grok. So these are generative AI models that are built with a lot of data, large data. Okay, so we, you know, uh, as a person or even ordinary enterprise cannot you can't build this LLM because you don't have the compute power. So we can build on top of these models or by using their brain and calling their API and this so as a result of calling this API, when we call API of an LLM agent, then what we are building on top of the LLM is simply an AI agent. Okay. So our model can now handle many tasks without custom training. Machine learning application no longer require massive data sets, and model like GPT-5, Claude, Gemini, and DeepSeek enable us to build natural language understanding, context awareness across long interaction, structured outputs, tool use, multi-step planning, reasoning and acting, which now drastically make it possible for many people and many companies to build on top of these models and have their own, a form of agentic system that can help them automate their task. So what can modern agents do? Okay, what can agents do that an ordinary workflow cannot do? So agents can interpret ambiguous situation. Agent can, think sequentially or in parallel mode. They can act autonomously without any instruction from human being. They can call tools. They can also call external system through MCP server. They can plan and execute multi-step tasks. They can also summarize documents. like large documents. They can work with unstructured data and both structured and unstructured data. They can also generate test code. They can automate routine tasks, what to do every day. You can, program it into an agent. An agent will just automate it for you. Or I read an article, was it 2 weeks ago, that Zuckerberg built what he called a second brain that will act as a CEO for him. Instead of him being the CEO, this second brain agent will integrate into every other person's agent in the company and will be acting as a CEO for Zuckerberg. So that is the capability of AI agent. These tools are powerful tools that can do anything if programmed very well. They can analyze text, they can analyze images, they can, analyze audio and video and many other things. They act autonomously, and they are built, by simple mathematics, rules, optimization, and strategy. So if you can program these four things into a system on an LLM as the brain, then you can build an agent that can solve any problem. So the first thing we want to look at in this chapter, this is chapter one, which where we have introduction to agents. So here we'll be looking at basic reflex agent with simple to use. Okay, so we are going to explain most of this term, and then you are going to understand everything. So in this chapter, we'll build a simplest possible agent, which is called the reflex agent. So what is reflex agent? Reflex agent is an agent that can perceive a query input. It can match the input to a rule or a tool, and then it can respond immediately. No planning, no memory, no past conversation. In other words, a reflex agent does not need a memory, it does not plan, it does not think or reason. It only acts sequentially based on a query and tool. And when you have a query and a tool and then you combine them sequentially, then a reflex agent can act and perform based on the sequential arrangement of the tool that was programmed into the system. So think of it like a thermostat, okay? So a thermostat reacts to accurate state, nothing more. It just reacts. So those are what a reflex agent can do. We also implement the react pattern, which stands for reason, act, and observe or co-observe. So reasoning is the ability of an agent to decide on what to do. Acting is the ability of an agent to execute a tool, and then observe is the ability of an agent to interpret the result of the action it has taken. Okay, so this loop is the foundation of how modern LLM like Claude Code and OpenAI GPT also work. So let's look at what we have in our step one. So to build a simple reflex agent that will perceive a query, match the query to a tool, and respond immediately to the query, we have to import these Python libraries. So we are not using LLM API here. So we are just, this is just a demo to showcase how Reflex Agent, which is the simplest form of agent, works. So the first thing we'll be importing EOS, then we'll import JSON, and from typing, import list, date, any, and callable, and then from date time, import date time. And then we are going to run this cell. So the set already run. So we have our modules that we want to use imported. Step two, the simple tool class. So for any agent to call a tool, you must define the tool. A tool is a function that allows an agent to solve problem. A tool, just like we have mathematical functions that are designed to solve particular problem. Like you have logistic function, which solve logistic problems. We will have many function, many mathematics function. So tools in agent are also functions that allow the agent to solve problems. So you can design a tools to, perform simple arithmetic operation. You can design a tool to, display weather at a particular time. You can design a tool that will help you check time and tell you what the time is, and so on and so forth. So tools are just Python functions that you program to solve a specific problem. So a tool is a capability that the agent can use, like a calculator or a clock. Every tool has three things, okay? So every tools they have these three characteristic. First is name. A tool must have a unique name, a specific name, because you can't call a person without knowing the name of the person. So also if you want to call a tool, the name of the tool uh must be clearly defined. Okay. So a tool must also have what we call description. So what it does, for example, if you are solving an equation, of course you have the step of the equation, you have the formula, and then you have the steps to arrive at the final answer. So, and then you know the description of the equation or the function you are working with, and then you can describe it. For example, you can tell that logistic function is a kind of function that is used for solving a logistic problem, and so on and so forth, just like that. So a tool must have description. The description will allow you to know what the tool can do, what it does, and the specific capability of the tool. Then we have function. Function is the actual Python callable that runs when invoked. Okay, so a tool has a function. Function is, the capability of the tool. That is the problem that the tool can solve when it is called. That is its function. Okay, so in simple terms, we can just define it that way. So this mirror exactly how Claude goes to also work in the real API. So tools have name, they have description, and they have function, which is also known as the input schema. So let's define this the simple tool class. So this class is going to have house all the tools that we use in this reflex agent. The first one is let's define the class simple tool, and the description is a base class for agent tool. So let's define the name of our tool, the name, the description, and the function. So in a Python callable function. So we have self.name name, self.description description, self.function is function. So this is what we have as the three properties of the tool, the name, the description, and the function. Then, of course, execution. So we are going to execute the tool with this execution function. So return self does function works. Then the get schema. That's get the schema of the agent. Return to schema for agent. Return. So when we call this get schema function, it's going to return the name, that self dot name, the name of the function or the name of the tool, description, that's the description of the tool. So let's run this. So we have that. So we've defined the simple tool class. So this class gave us the blueprint of what our tools will look like. Now let's go to step 3. So now that we've defined the tool class, we can go to step 3. Step 3, the reflex agent initialization. So the next thing after defining the tool class is to initialize the reflex agent. Remember, we said reflex agent is an agent that acts sequentially based on query to and tool execution to generate an output. Doesn't have memory, it does not have episodic or procedural or working memory. It just acts based on the tool that it has and the query that is given to it. So the agent itself holds the registry of tools. That's a dictionary keyed by tool name, which we have just initialized in the class above. A conversation history, store past query plus response, and the history limit to avoid unbounded memory growth. So we have the history limit, which will, allow you to manage the memory. This agent does not connect to any LLM yet, so we are just doing a demo, no LLM involved yet. So this is just direct functional programming. So let's define the reflex agent. Let's initialize the reflex agent class. So class reflex agent. So the description, simple reflex agent that responds to stimuli with actions. Implement basic react pattern, reasoning, action, and observation. So you can see the initialization of our reflex agent. Have init, self, name, string equals to reflex agent, then self.name equals to name, self.choose as dictionary, and it is string simple two. So we are defining simple two registry. Self.conversation history, which we map to list dictionary string. And then we have this dictionary of string, that's the memory size. The memory size is maximum history, which is 10. So it can keep, 10 queries at a time. After that 10, it will not keep any query again. So def add two. So this function is for adding two. The first one is initialization. The second one is for adding two. So self two, simple two, register a two with the agent self dot two, two dot name equals to two, and then print. So this function we add the two. The first one is initialize the reflex agent. The second function is to add two to the reflex agent. So I'm going to run this function now, and then we have it run. So that is step 3 of building a reflex agent. Step 4, tool selection. Now that we've initialized the agent and we have defined a function for adding tools, the next thing is to, you know, program our tool selection and its limitation. So select tool. This of function here, select tool. Decide which tool to use by scanning the query for keyword. For example, we can have keyword like calculate, math, compute, which all belong to the class calculator. We have time, date, when, which all belong to the to get time. We have weather, temperature, or these are entities that are mapped to specific tool, which belong to weather. So this is intentionally naive. Okay, so this is just an example. So what happens if the user types in what is 5 plus 3? So because in this keyword there is no plus, we only have calculate. So that means the two calculator will not work for 5 plus 3 because the only word we have here is calculate, math, compute. Any word outside this will not function in the two calculator. So it will fail because plus is not in the keyword list. This motivates LLM based tool routing in later chapters. So we'll be looking at this in subsequent courses. Then reason. Simply describe the decision in plain text. It's logging step, not real reasoning. Okay. So reasoning allow the agent to, decide on which tool to call and, how to route the query to a specific tool. So let's debug and run this function. Let me just debug it. So remember, this is generative AI coding. So we are going to be using Claude a lot to debug most of our system. And okay. So let's walk through this tool selection and its limitation. So we have this def select tool. That's the function to select a particular tool. Self query string map to simple tool. We have defined a class of tools where we initialize our tools called simple tool. So simple keyword based tool selection in production use embeddings or LLM based selection. So this is just a practice code. You're not going to program production or AI like this. Okay. So query underscore lower equals to query dot lower. Okay. So that is when it will allow you to pass in a query, and then if any word in query underscore lower for word in calculate, math, compute, that's our keywords for calculator, return self dot two dot get. So whenever any query contains this word, the tool will route the your query to calculator. Okay. If any word in query underscore lower for word in time, date, when, return self.to.get time. So whenever any of your query contains time, date, and when, the you know function will route your query to the to get time. And also whenever your query contains the word like weather and temperature, the the function will automatically also write the agent will route your query to the to weather, get weather, which will return the information. Okay, so that's what the first function does. Then the second function, reason, that's decision. So the first function allow you to select a tool based on this keyword. The second function allows you to, you know, allow the agent to reason based on the query after selecting the tool. So reasoning step, date time, what to do. Two equal to select dot self dot select to query. Okay. So if two return F, I should use the two dot name two to answer this query, else return I don't have specific two for this. So when you run when this function is run, what the agent would do is to check your select tool, check your keyword and the tool they belong to. So if the word is correspond to a particular tool, it will call the tool. Otherwise, if the word does not correspond to any tool, it will return this statement. I don't have specific tool for this. You understand? So that's what this function does. So I'm going to run the function now and then the function as well. Okay. Step 5. Hope we are following. So step by step, two selection. So we've done two selection, how the agent select two. Then step 5, react loop. Remember, we are using reasoning and acting. So how does the agent act when it has selected a tool, when it has matched your keyword to a particular tool and it has selected a tool. So we are going to be using this function act, execute the tool. Okay, so once a tool is selected, act will pass the query to extract parameter and call the tool. So for the calculator, it manually extract number from the query string again. So this is crude. We are not using LLM API, yes. So this is acting function and this is observe function. So it based on what the tool that is being executed, then observe we interpret the result. So simply format the tool output into human readable observation. So when it's called a tool and acts on the tool based on the query, then it will observe, that is, interpret the result of what it has acted on based on the query, and then it will process this function process will process the full loop. This is the main entry point. It runs the three-step in process. So this is just like the coordinator. Okay. So this is how the sequence works. You pass in your query go to reasoning, and then from reasoning it goes to acting, and then from acting it goes to observe, and then after observation, that's interpreting the result, then it passes your response as an output. Okay, so that is how it actually works. So we have these functions. So we're going to be running these functions now. Okay, we'll just debug some of the things. Okay, and then we have this. So based on what we have, we have act, observe, and you have your response. So the first function is acting function. That's action step. Execute the selected tool. So this function enables the agent to execute the tool that it has selected. And then so we have the process there. Return to result, no specific to selected success false. So try if to dot name is calculator, and it will check through the query and calculate whatever is in the calculator. So it will check through this word, add, subtract, multiply, divide. So presently, this is what we program into our calculator. This is what the calculator too can do now. It can add, subtract, multiply, and divide. So else, two dot execute two like get time, needs no ask. So two name, result, success, and then you have your result function. Then observe, that's observing the output of the result. Save action result, observation step, interpret the action result. If not action result success, return F action failed. Okay, so that is if no tools, there's no tool to call because maybe the keyword is not in the keyword we defined, it will return action failed as well. Then the process. So that's the coordination that will coordinate the agent from the beginning, from reasoning to acting to observation. So self query string. So main react loop, reason, act, and observe. So print self dot name processing query. Reasoning is equal to self dot reason. So this will process the reasoning function, and this will process the acting function, and this will process the observe function, just like that. And then this is where you have your response as the output based on, the observation. So saves to history. So it will, remember we set our memory to 10, so it can save up to 10 response. So it will save this statement here will append, the response into the memory. And if the length dot conversation history is self dot max history, self dot conversation history dot pop 0. So remember we program it to 10. So if it when we keep up to more than 10, then it will no longer save. Just return it. So let's run this function to see. So we've run the function, and this is how step 5 goes. So this is how we can define the React loop. Okay, so step 6, history and tool listening. So remember, we stop at save, conversation as history. So history and tool listening. So two utility methods on the agent. Get history, that's return all stored interaction, useful for debugging or review. And we have list tools function, return the schema of all registered tools. So this close out the reflex agent class definition. So the first function we have here is get the history of our chart with the agent. Let me quickly debug this. Sorry about that. So I need to return this back so that the alignment can work. And then we have our alignment. Okay, so the first function is get history function. Return full conversation history, self.conversation underscore history. And then this next function is list to function. This all register to and their descriptions. So let's run this function. So the function has run. Step 7, tool implementation. So we've run the history and tool listening. Tool implementation, how do we implement our tools? These are the actual functions that power the tools. They are plain Python, nothing agent specific here. These are plain Python functions designed to solve problems. Remember, we've defined our keyword that map to the calculator function. We've defined our keyword that map to the get current time function. We've defined the keyword that map to the get weather function, which simulates hard-coded data. Okay, so in production, we are going to be calling the weather API, not hard-coded data. Okay, and all these tools are function, and then we have wrapped them in the class that we defined in the in the second step of the lesson, which we call simple 2. We've initialized them in simple 2 class. So the last function here, which is function get weather. So in this function, we are going to pass in location, which is a string, and it is unknown as the first definition, or mapped to string. So the description of the function is that simulated weather 2 in production, call a real weather API. Remember, this is just a demo. We are not deploying to production, just to understand how Reflex agent work. So we are not using a weather API, just hard coded data. So weather data is defined as temperature 72, condition sunny, humidity 45, location as location. So we have this dictionary, the keys that map to the value as our weather data, which is hard coded. And then this function will return a JSON.dump JSON.dump weather data indent. So this function will store the JSON data. We store the data in JSON format into this weather data memory. Okay, remember we also have like a temporary memory we defined. So let's run this function, and our function ran successfully. So we have our functions, which are just our tools. So we are going to be calling these tools now: calculator, get current time, and get weather, in our next step, which is step 8. Step 8, we are going to run our demo. Remember, we started from step 1, step 2. We define our tool, we define our agent class, tool class, and then we define the tools, and then we are going to call them now. So we are going to assemble everything together and watch the agent in action, how it performs and how it works. So we have this demo. First, create a Reflex agent, which was our first thing, which we did above. Then we register the 3 agents. We register the 3 tools under the agents, and then we run the 4 test queries. We have queries which follow the pattern: recent, action, and observing, and then print the conversation history. So the demo is going to run to 1, 2, 3, 4, and then we are going to have the output. So what the recent action observe output, that's the react loop running. So this is our function to run everything together. So agent, we are calling our agent now. Remember, we defined our agent above. So Reflex agent equals to name demo agent, register tools, agent.add tools. So it's going to add tools calculator, it's going to add to get time, and the function of the get time is to get current time. The function of the calculator is to get calculator. Remember, a tool always has a name. All tools must have a name, a description describing what they do and what they perform. Remember, our calculator operation can add, subtract, multiply, and divide. And then the function of the tool, which is to calculate. Then we have our add tool, simple to get time. The description is to return the current date and time, and the function is to get current time. Okay, and then we have the other simple tool, which is weather. The description is for it to return or weather information for a particular location, which we had coded, and the function is to get weather data. Okay, and then print agent initialize with length agent.toTools, print available tools. So let's run this and see all the available tools. Then this function has run, this cell has run, this pipeline has just run, and then we have our demo agent. Register to calculator is registered, the tool get time is also registered, and the tool weather is also registered. So we have our agent initialized with 3 tools, and then of course we know their function and we know their description. So the available tools are what we have there. So let me just remove this under our Reflex agent. So the next thing is to test the query. So test query, what is 15 add 27, calculate 100 multiply 5, what time is it, what is the weather like, and then we can run this. So it will print run test, that's the header, and then it will generate all we need. So this is our test query, and then the next thing is to run all the agents together and then we see how we fare. So I have run the agent, but let me just run it again so we can see what just happened there. So this is all we have done. Remember, we defined our simple 2 class, and then we define the reflex agent class and the functions to run it. And then the next thing we did was to define a process to show how it reasons. That's reasoning, acting, observing, and responding. So it's when it gets a query, it reasons, then it take action based on the two, and then it observe, that is observe which tool to use and map a specific query to the tool, and then it generates response, which is the output of the query, and then it store the history in a temporary memory where you can then call later, and then it maintain history limit up to 10. Remember, we defined it to 10, and then you can get the history and see what you have in your tools. So these are our two implementation as we have discussed, and so this is our test query that we have run in our notebook, and then show history. So this function is going to show us the history and how the test query work. Let me run it again so we can see. So this is the outcome, guys. So the key concept we have explained and everything we have discussed is registered there. So let me just expand so we will see what we have in our agent. So query, what is 15 at 27? The response, I apologize, but I encounter an issue. No specific tool selected. So we did not select any tool to run the query, and it run at this time. Calculate 100 multiplied by 5. Based on my analysis, 500. Remember, why is this query not working? Remember, we don't have add. We don't have any tool that is add. Remember, when we pass definition function into our tool, there is nothing like add. So based on the analysis of what we program, there is multiply. So this query calculates 100 multiplied by 5, so it could add this intent to calculator. So it multiply 100 by 5 to give us 500. Then what time is it? Based on my analysis, 2026 05 21, and this today's date, and the time now is 15:05. What is the weather like? So based on my analysis, the temperature, remember we hard coded this, so it's not using any weather API for now. So it returned what we hard coded into the system: temperature 72, condition sunny, humidity 45, location unknown, and the time that this query is returned we have there. So the key concept we have demonstrated basic reflex agent architecture, tool registration and selection, react pattern, reasoning and acting, conversation history and management, simple keyword based tool routing, and then we have everything as we have defined. So and then we ran our process and everything came out very well. So alright guys, so this is how you work with a reflex agent particularly, okay? And so this will be the end of our class today. So in summary, we've looked at what a reflex agent does, which is an agent that can just reason, act, observe, and give a response, okay, based on, you know, it also uses temporary memory, but it does not have you know, a RAG memory, and it cannot perform complex tasks. It just acts based on what is given to it and based on the tool that is available for it to function. So basic agent architecture, reflex agent.init, we have our tool registration, which is add tool plus simple tool. We have our react pattern, which is process, reason, act, and observe. And we have our conversation history, which is conversation history.list. We have our keyword based routing, which is select tool. So what is intentionally limited and why? So keyword routing is fragile. So we'll look at it in next chapter, where we can use LLM based tool selection. So manual parameter extraction is brittle. LLM extracts structure parameter naturally. So remember, we are not using any LLM API here. So we did not add any LLM API, just to practice how a Reflex agent works. So see you in the next lesson, guys. And remember to like and subscribe and encourage me. Bye.